So today you're going to take notes on how to write net ionic equations. So while you are doing this, you need to be referencing page 2 in your packet. Page 2 in your packet has an entire solubility table on it in terms of what happens when you combine different cations and anions together and whether or not they will be soluble or insoluble. So you're going to want to have this out as you are working. So solubility rules, go ahead and get these down. Most nitrates are soluble. Your salts that are in group 1, so your alkali metals and ammonium, are soluble. Most chlorides, bromides, and iodine salts are soluble, except those that contain silver, lead +2, and mercury +2. Most sulfates are soluble, except barium, lead, mercury, and calcium. Most hydroxides, except those in group 1, barium, strontium, and calcium, those are only slightly soluble. The nice thing is you will always have your solubility chart, so you won't have to memorize these, but those of you planning on taking AP Chemistry will have to have these memorized in AP Chemistry. And there's one other one, most sulfides, carbonates, chromates, and phosphates, they are only slightly soluble. So a couple of rules for writing net ionic equations. First one is that you write slightly soluble salts, gases, organic compounds, water, and complex ions as molecules. And then you write soluble salts as ions. You cancel spectator ions. These are the ions that are they're the same on both the reactants and the product side. We'll go through some examples with them. So some other information you need to know. Metals in their solid state are not ions and they do not have charges. And most oxides are written as molecules. And anything that is soluble, okay, has an AQ written behind it. Anything that is insoluble has an S behind it, and gases have a G behind it. So let's do an example. Here we have lead 2 nitrate combining with sodium sulfide. This is a double replacement reaction. I know that because I have 2 different compounds that are combined. So first thing I need to do is predict my products. The cations are going to switch places, and I form lead 2 sulfide and sodium nitrate. And I need to make certain that this reaction is balanced. It is here. It's a 1:1:1:2 ratio. Now what I do is I'm going to look up the solubilities of each salt in my solubility chart. And I see that my lead 2 nitrate and my sodium sulfide are both soluble, so they're aqueous. I put an AQ behind them. My lead 2 sulfide is a solid, and my sodium nitrate is aqueous. And now I'm going to break apart all of my aqueous compounds into their individual ions. So my lead becomes a +2. The 2 behind my nitrate is pulled out in front to give me 2 NO3 minus. Same thing happens with my sodium sulfide. The 2 from behind the sodium comes out front for 2 Na plus, and my sulfide is a -2 charge. On the product side, my lead 2 sulfate is solid, so that remains, and I break apart my sodium nitrate to 2 Na plus and 2 NO3 minus. Now I'm going to look for any spectator ions, ions that are the same on both the reactant side and the product side. And I do have one that I see here. It's my nitrate. I have 2 NO3 minus on my reactant side, and I also have it on the product side. So I'm going to eliminate that from my equation. I also had an Na plus on the reactant side and on the product side as well. So those are eliminated. I'm left with only the ions that actually take place to form the solid. So my Pb +2 and my S2 minus forming my solid lead 2 sulfide solution. One more example. I have zinc combining with iron 2 chloride. This is a single replacement, so I'm going to want to check my activity series and see if zinc is more active than iron, and if it can kick it out, and it does, form zinc chloride and solid iron. Now I'm going to look up the solubilities of my iron 2 chloride and my zinc chloride on my solubility chart. My zinc and my iron are solid metals, so they're going to remain. I do not need to worry about their solubilities. They are insoluble. So both chlorides are aqueous. So I write them with their respective states behind. So solid zinc plus iron 2 chloride in its aqueous form, zinc chloride with aqueous, and solid iron. Now I'm going to break them apart into its individual ions, anything that's aqueous. So my zinc solid remains, and I have iron +2 plus 2 Cl minus. The 2 comes out in front when you're forming the ions. Form zinc +2 and 2 Cl minus with my solid iron that's left. Now I'm going to look for any spectator ions, and I do see that I have one. I have 2Cl minus on both sides of the reaction, so that is going to be canceled out, and I'm left with solid zinc plus Fe2 plus forms zinc 2 plus solid iron.